Let us go into details of which gases are classified as greenhouse gases. Okay, now there are many gases in our atmosphere. You can oxygen, argon, helium, hydrogen, many gases there are in the atmosphere. But for us, not all gases contribute to climate change, and that means that not all gases are greenhouse gases. Okay, so greenhouse gases are gases which trap heat in the atmosphere, you can say on that part. Now, of course, CO2 is one of the major greenhouse gases, but as one of the participants mentioned, methane is another greenhouse gas. But there are total around 7 greenhouse gases which are contributing to climate change, or you can say to increase in the radiative forcing. Just so clear on the terminologies before we go into the gases part. So global warming is basically refers to a long-term increase in Earth's average surface temperature due to accumulation of greenhouse gases, which is basically measured in watt per square meter, or you can call it as a radiative forcing. But when we talk about emissions, it is the release of greenhouse gases into the atmosphere, and then it is from sources like energy production, transportation, agriculture, and industrial activities. Now, when we talk about greenhouse gases, there are 7 types of greenhouse gases which are there. So carbon dioxide, methane, there is one more gas which is there, which is not mentioned in the slide, but it is nitrous oxide, N2O. Then hydrofluorocarbon, perfluorocarbon, nitrogen trifluoride, and sulfur hexafluoride. We will go into details of each from a natural source perspective as well as a man-made source perspective. But when we talk about climate change or greenhouse gases, please remember that these are the 7 gases which are there, which are responsible for climate change or increase in radiative forcing. Okay. Now, if we talk about, Ankit, allow me to finish and then we will take questions on this part. If you have any urgent question, you can put it in the chat, please. Thank you. Now, if we talk about sources of greenhouse gas emissions, of course, one way to look at it is any source which has a carbon. Because you burn carbon, you get energy, which is a positive externality. But at the same time, because you are burning carbon, it reacts with oxygen and it produces CO2. That is a carbon dioxide. So you can say any form of fuel, be it coal or oil, natural gas, because these are primarily carbon or hydrocarbon, you burn it, you get energy, which is required for our use. But at the same time, you get CO2, which is a negative externality of such process. So if you talk about sources of GHG emission from CO2 perspective, powering of buildings, because you get electricity, you burn CO2 for, like in Europe, we require heat. So you burn natural gas, you burn coal, then transporting goods, people, be it in railways, road, ship, all of them use fossil fuel. So that is what is resulting into CO2 emissions. The other aspect is to see from an agriculture and livestock perspective as well, because there is a lot of emissions happening because of application of fertilizers, burning of agriculture residues, rice cultivation, as someone was mentioning. So all those are also sources of GHG emissions which are there. But at the same time, when we talk about the solutions for this is like electric vehicles, wind turbine, hydrogen fuel, etc. But of course, please remember that to produce these vehicles also, we have to emit some emission, but of course, they result into much lower emissions during the operational stage. So overall life cycle perspective, it is a much better option than what we see in a conventional way to look at the energy transport or other activities for our day-to-day requirements. Sources of CO2 emissions or other greenhouse gases. Of course, there will be both natural and human sources. I think Kastub sir was asking how that variation is happening in terms of climate or something like that. So, of course, there could be some tipping points or a major events during those time through which natural events, more CO2 might have released into the atmosphere. It could be volcanic outgassing, organic matter burning, natural decay, and then, of course, aerobic, like we as an organisms also exhale CO2. So those are some of the natural sources of carbon dioxide you can think of when we talk about the CO2 emissions. But other sources which are there, which I would not call it as a human source, but more like a anthropogenic because of human induced activities, you can say. So it could be burning of fossil fuel, creation of cement, metals, many other aspects are there on that part, heating, power generation, forest fires or deforestation, land clearance, because when you change the land pattern, there is also CO2 release which can happen on that part. So one of the major reasons for CO2 is, of course, the coal, natural gas, or I would say oil consumption, which is primarily a reason for our CO2 emission. And I think I will cover in subsequent section to show you what is the contribution of such fossil fuel in our CO2 or global warming as well. But I want some of the participants to respond. Okay, what according to you would be the consumption of coal, oil, and natural gas from a global perspective? Or if not global, at least from an Indian perspective, just a wild number or wild guess you can do in terms of billion tons or something like that. So just to bring that perspective to you on the scale of which we are talking about the emission reduction, what could be the annual consumption of coal in the world or in India? Or say for that matter in Europe or China as well. Any guesses? Or say coal, oil, natural gas? Anyone if you know? A wild guess? In the chat window if you can. Okay. Or 100, Shubham, I think you are showing a very small number, 1,000 million tons. Okay, of course, from India perspective, I think you are near to that number. 90% of total emissions, correct? Okay. Now, I think just to bring that perspective, I had added this slide on your to understand why this is a major contributor. Like in 2024, we consumed around 8 billion tons of coal. And if you put it or convert it into emission perspective, it will be between around 16 to 20 billion tons of CO2. The second highest contributor in terms of fossil fuel was oil, with around 5 billion tons we consumed in 2024. And if you put it from an emission perspective, it is around 15 million tons of CO2 in 2024 just from oil consumption. And when you talk about natural gas, the consumption was around 3 billion tons of CO2 in 2020. 3 billion tons in 2024. And if you put it in the emission perspective, it will be somewhere around between 1 to 2 billion tons of emissions coming from a natural gas. So if you will collectively see 20 from coal, 15 from oil, and 1 or 2 from natural gas, 36 to 37 billion tons of CO2 emissions just come from the fossil fuel consumption in power generation, in industry, or any other way to utilize it as an energy for heating purpose, say in Europe, for example. Now, coming to the concentration of these gases, is you will notice that the unit is very much different here. So when we talk about CO2, it is parts per million, or you can call it as a milligram per meter cube. But when we talk about CH4 or N2O or SF6, the units are quite different. And you will see that it is measured in parts per billion, which means that to measure that, I have to go a layer down in the units because the concentration of gases are very small in the atmosphere of such gases. So that's why you will see that the units are also slightly different in that part. If I put it in ppm, then I think this number will be 0.00934 or something like that, which will not make sense when we measure it or when we read it in our regular day-to-day activities on that one. So here you can see again the CO2 CH4 concentration is increasing. Then again on the N2O you will see that the concentration is increasing, and same with SF6 the unit is much more less, which is parts per trillion. So PPT they call it. ppb is billion and ppm is million. So again the concentration of SF6 is very less in the atmosphere, but still it contributes significantly to the global warming. One insight which I wanted to share with all of you is that when we see the 7 greenhouse gases which are there in the atmosphere, okay, CO2, CH4, and N2O are naturally occurring gases in the atmosphere, which means they have their own cycle. For example, I think Pratiksha was asking about carbon cycle in the quiz. So there is a carbon which gets released, get fixed into the, trees, etc. And then that cycle works on the CO2 part. Similarly, there is a methane cycle, there is an N2O cycle. But when we talk about the other 4 gases, which is PFC, HFC, SF6, these are all man-made gases in the atmosphere. They are not naturally occurring gases. So you will also see a trend that these measurements are only available from 1850 onwards because these gases were not present at all in our atmosphere. So that's why these gases are, you will not find much data from a historical point of view because these were all started because of man-made actions to produce these gases for our requirements, and that's why you find those concentration in the atmosphere now. So this is the question which I wanted to ask. So what is the most common greenhouse gases according to you? CO2 or CH4? Or you have any other answer to it? CO2? Okay. Okay. Any wild gas? CO2? Okay. Okay. H2O, I think Subham has rightly highlighted. So one of the most common greenhouse gases is not CO2 or CH4, but it is water vapor. Because water vapor also is able to trap heat in the atmosphere.